Hello, everyone. Let's work. Okay. Hello, everyone. I'm Vaibhav, and presenting with me is Konstantin. We work in the static analysis and automated refactoring team at Bloomberg, which focuses on analyzing and understanding all of Bloomberg's code base. This team is a part of developer experience, which builds common tooling for all of Bloomberg's developers. So we'll start with some motivation behind this talk, beginning with why static analysis pipelines are valuable to us. Then we'll talk about some aspects of source code at Bloomberg, and roughly the kinds of tools that we want to use in this pipeline. Later on, there'll be a couple of examples. I'll take one. Konstantin will take one example, and there will be time at the end for questions. So, Bloomberg has a lot of code to be analyzed in the hundreds of millions of lines, and the code itself has a complex dependency graph. It's also in a continuous state of change with almost 2 million weekly package builds. And this amounts to like many years of CPU time being spent building packages. The build systems that we use roughly is like almost all of it is CMake with occasionally custom make files here and there. And it's also like a distributed source code model. So you can have monorepos, you can have your own repository, you can use someone else's repository you can use the libraries that someone else publishes in your own code. But the code itself will be in separate places. It's also built together in something called a consistent distribution. We'll talk more about this later. So why do we build static analysis pipelines? The main takeaway from the last slide was there is a lot of code and it changes really quickly. So we need some kind of structured way to introduce tooling that isn't just the compiler. This lets us detect issues early and introduce new tools and new and custom tools that could just go beyond like WAL and WError. We've done this in a few cases. And one example would be you could have one tool that could detect, that could fix includes, or that could retire feature toggles or detect deprecated APIs and then replace them. The last but not least is you have a central view of all the released code and what it means, air quote means. So there's a couple of broad categories of tools that are interesting to us. It says 3, but the first 2 are actually part of something that you could use in an interactive development loop. They're usually fast enough. They're usually like a really dumb example would be, like a really simple example would be to just your compiler with W unused variables, for example. Then client ID would be another one with a limited set of checks. Then the other category is things that are better phrased as offline tools because they are generally part of a multi-stage process. For example, you could collect data in the first step about the call graph of a function and then use it later to infer some other piece of information. Among these is also things like static security analysis. So let's look at our first example, which is gating package releases in real time. So I talked about this thing called a consistent distribution some time back. What is it? So a distribution, the best way to think of it is a directed acyclic graph of packages that must be built together. All the packages in a distribution are built from source, and distributions can extend one another in specific and meaningful ways. So you can have distribution A, which says include everything from distribution B, excluding packages D, E, and F. And when you publish packages, they all must pass mandatory checks. And before they're considered released, they must pass the checks, obviously. So these checks can either be on the contents of the package itself, or it can be some condition on the entire reverse dependency graph. For example, potential regressions that might happen if you release a package. So while the checks themselves are usually really lightweight, if you're going to run something on the entire reverse dependency graph of a package, you don't want to do it as a part of the release pipeline, because that might hold it up, and that's really bad for developer experience. So this is where we come in and fill in the need for like a real-time analysis pipeline that runs in parallel with the release pipeline. So on the top, you have a rough slice of the release workflow as it is today. The first, you have the promotion step, which is basically a release. Then you have the configure, then the dependency graph rebuilds, then you run the checks, and then you finalize your package. We hook into the post-build step in this because that is the point where we have all the information available that we need to analyze the package. So the challenge is to be able to finish it before the checks are actually run. This is usually possible to meet, but gets challenging if you're, let's say, analyzing something that is foundational or like a root in the DAG, because that might have a large, that will have a large reverse dependency graph, and computing checks on all of the individual packages that are affected by this might take some time. And so once we're done with the analysis, we forward the checks to a separate API that does some pre-computing before that pre-computes the checks, and then they're called on later. We'll be focusing mostly on the red box going forward. So before this, we had something. We had a ingest source code box. So what's happening there? Let's zoom into it. I said earlier that we have all the information available at the post-build step. What I meant by that was we have knowledge on how to build each and every translation unit from the compile commands file, so that you know all the flags that are relevant to a C++ TU. And you also have access to all the source level dependencies of the package. For example, that would be all the possible includes that you want to, the entire include graph. We use the data from the compile commands to capture all possible dependencies of a source file while ignoring preprocessor conditional. So if you have two pound includes, and during the compile step, only one of them would get included because of some define, we will get both because we want to over-specify rather than try to get a different archive, try to get a different dependency graph for each possible set of flags. What this does is you have the same set of files irrespective of your compiler defines. And then these files, the paths to these files, and they're also normalized later so that it's really cache friendly. Oops. Yeah. So moving on to dispatching jobs and running tools. This is the step where once you package all the source code and its dependencies together into an archive, it gets shipped to a cluster that matches it with a matrix of quote unquote fast tools, things that can run in enough time to finish before the checks are beginning. And each tool can specify what kinds of source archive it can interact with. So you can have tools that are specific to C++ or JavaScript, or tools that say I'm only C++. So another benefit of this is that you can manage capacity for each tool individually, because sometimes you might have tools that are limited to a certain cluster or are required or require more compute than others. So by annotating each tool, you can be really specific in how it ends up getting used, and also have more control over the performance of that tool, or the throughput, actually. So once all the analysis is done, we will take the diagnostics or anything else our tools emit, along with any files that are generated in the workspace, and then package them up. So what were the challenges with this? Mainly, we feel that the parsing effort is duplicated in this, because almost all of the tools that are built using libtooling, they need to parse the same source code over and over and over again. Something we're looking into to solve this is to use serialized ASTs as potential inputs, but we haven't really looked that deeply into it yet because there's some concerns about stability and hashability. Then the next big problem or challenge in this case would be how do you generate metrics on regressions? Because I think most C++ compilers don't have any stable identifiers or hashes for diagnostics. So there's no way to, I think only MSVC has identifiers for diagnostics. I feel someone can correct me if I'm wrong. But there's also no hashes that go with the diagnostics that can link it to the piece of source code that it's talking about. So you can have what this does is most heuristics become either you need to come up with your own custom hashing that considers the source range of an error along with the source code that it's targeting, targeting, yeah. And then use this to match up, or you need to settle for the fact that regression metrics will be approximate if you don't have anything like this. Then the last problem was like you can have, because the source code is distributed and the build itself is distributed, you can have situations where some interesting problems come up. For example, if a file moves between package A and package B, and the builds are misaligned in really specific ways, you can have files that actually disappear before and then show up later. When in reality, it never actually disappeared, it was a move operation. But both package A and package B that existed at that moment in time did not have the file because it moved from A to B, and B hasn't built yet. And the other problems is analysis results can also change because due to a slightly different dependency envelope, because it's because that's just the nature of the problem. Okay.
Okay. We have many different source-to-source Bloomberg-specific tools, transformation tools, and I will discuss our feature toggle retirement tool. So feature toggle switches is a common design decision in huge corporations. So when you have very, very quickly modifying code, you want to test it really well on the real data, say on market data, which comes to beta environment, not to dev environment. You want to decouple the rollout and the enablement of the feature. So for instance, you want to implement the feature in the binary, compile it, deploy it all the way to prod, and then gradually, maybe within a week or two, enable it on beta, test it there, and then enable it on prod. And if something goes wrong, you want to disable it quickly. This is made by central database, like key value store. Key is the feature name, value is Boolean, true or false. And this database is specific to the machine. So you have default value for the company, and you have values for the cluster, stage, up to individual machine or even user of the product. So it is very, very handy and nice thing, but if we do not garbage collect these feature code, which looks like here on the left top corner, it is the most simple thing. So it is just an if block with predicate. Predicate makes access to the central database and then either enables or disables this code. If we do not garbage collect this thing, we will end up with a huge decision tree as a program, so which is horrible. And so, of course, we want to remove it. What is nice here is that the interface is very well defined. the value which is returned by the feature flag is essentially a compile time constant. We know it at compile time. We can always request the database. It is a single accessor, at least in Bloomberg case, just a Boolean predicate. And it should be really easy to remove. It is mechanical in some sense. And it should be removed very carefully, because once you remove the feature, you cannot undo it on the machine, right? So if you introduced the feature flag and introduced a broken feature, you can always disable it. But once you remove the feature flag, you cannot disable this removal anymore. So it should be done carefully. So as I told you, on the left top corner, there is an example of the feature flag, and on the right top corner, there is what we want to achieve when this predicate returns true. At the bottom, we have another simple example where we have just two different features which depend one upon another. So it is a typical situation when you need to enable one feature in order to use another, to be able to enable another. So here we want just to correct the Boolean expression. This is an approximate design of our tool. So it reads the source archive, the feature flag manifest, finds out all the places where we use feature flag, and then creates replacements. These on the left is the example of AST matcher. On the right are what we match. These are basic blocks because we have AST matchers which are recursive. They call one another, so we can match any control structure which is made of these blocks. So ifs, binary operations, and ternary operation. This is how this tool is baked into our pipeline. And what are the challenges? So one of the major challenges is the testing code, where we have overrides for features. Here the problem is that it is not obvious whether we can remove the last two lines or not. Another corner case, it's this is a nice idiom when you cache the feature, but unfortunately, in this, when you cache the value of the feature flag, unfortunately, if you just replace the accessor with true or false, you will not change the if statement. So we need some constant propagation. Another challenge is this very interesting feature of C++ that we have. We can have ifs with elses and ifs without elses. So in this situation, we cannot just remove this the inner if, but we need also to remove else, and of course macro conditionals. So based upon our work with these and other source-to-source tools, what we have that we collected some wish lists for clang and clang apply replacements. Thanks. So yeah, measures for macros, and clang apply replacements is a wonderful tool. It has wonderful input language, but we would like to have it stabilized. So we would like to thank you for listening and thank our teammates for working with us. So any questions, please? Sorry, had to rush.
We have time for a few questions.
Yeah, I'm sorry, it shows 3.
Hello. Okay. Oh yeah, thanks for the talk. I had a question about the diagnostics. As you said, I think you there was like no identifier for them. So are you assuming that the compiler is going to change? Because if the compiler doesn't change, then you can sort of like put diagnostics into a set. It's just kind of you just have to go through the manual process of, getting the enum number of the diagnostic. Like, you got to hash the source ranges. You got to hash all the arguments and stuff to the diagnostic. So it's doable. It's just a bit of a pain. Is that just the problem? Like, it's just a lot of work, or there's something more fundamental that I'm missing?
As far as I understand, relying on the enum numbers, that there's a fabricator on this where the discussion happened. That I think we were planning, not we, the implementer was planning to use the enum names, but the problem is that it gets tied to the implementation that is using. You can't change now you can't change the name of the enumeration thing, and it also, so in principle, what you're saying is correct. Like the compiler can be extended to just dump out the enum number, and we can assume that it's stable enough. But it would be preferable, like if you have like a stable opaque identifier, that there should be no meaning to it beyond this is error number 623, and then you can associate a lot of other metadata with it.
Yeah, that makes sense. I mean, you could also just do, it's terrible, but I think what I did, because I had to do something similar, I think I just hashed the string representation of the diagnostic along with the source locations, and that worked good enough for the prototype I was working on.
That's roughly what we came up with.
Okay, I'm not the only one then. Okay, thank you.
Hi, with the feature flag removal, have you run into locals with destructors being inside the if, and then if you remove the if and the braces, do you remove when the destructor runs?
Yes, of course. That's why on the very first example, we did not remove these parentheses. Okay. So that's one of. If we have a block, an if block with local, say mutex, right? Then if we remove the block, remove the parentheses, we will make this mutex global to the function. So it will not be released just ifs. So it's like
it's not showing up there.
Okay.
Any other questions?
I have a question about the package distribution related. So one of the things we usually of everyday build system. The problem is that, for example, B dependent on A, C is dependent on A as well, and with a new A released, B built successfully, and C doesn't. So when you have an application D dependent on B and C, you get different A's embedded in it. I'm wondering if this is some kind of problem you guys have solved with your entire package distribution.
Sorry, could you repeat again? Is the graph like A?
So there, at the bottom there is A, and B and C all dependent on A. And then when there is an A release, and B builds correctly, successfully, so you have a B with our new A. And you have a C dependent on A as well, but a C failed. And you have an old build of C, which is dependent on old A. And when you have a binary dependent on B and C, now you have two versions of A embedded in your binary, which could have different headers.
I'm not entirely sure on the details. I don't think it's possible for us to have two versions of A. So what happens is, if you have A and then B and C depend on A,
yes.
Whenever you say release A, both B and C will get rebuilt. And
yes, but one gets successfully built, the other one doesn't.
Yeah, and then the release would be considered failed because one of your dependencies failed to build with you.
Yeah, but the old build is still there, right? And when you build your application, you cannot say that C does not exist. C still exists, just as old C, built with old A, right?
Oh, I see. Then even there is no new B as well, because if there's no new snapshot version.
That's how you solved the package. Meaning, if there's an entire package, one failed, everything failed.
Yes. So everything must work together.
Thank you, Konstantin, and thank you, Vaibhav. We'll reconvene in about 5 minutes. We have an hour-long tutorial session coming up after that. Let's thank the speakers once more.